Intriguing correlation between earthquakes and cosmic radiation. There is a clear statistical relationship between global seismic activity and changes in the intensity of cosmic radiation recorded near the Earth's surface. Inform representatives of the Institute of Nuclear Physics of the Polish Academy of Sciences. This could potentially help predict earthquakes, but this correlation has yet to be clarified. Strong earthquakes usually result in many human casualties and huge material losses. The scale of the tragedy could be significantly reduced if we had the ability to predict the time and place of a cataclysm. As part of the CREDO project, initiated in 2016 by the IFJ PAN in Kraków, an attempt was made to verify the previously known hypothesis about the potential possibility of predicting earthquakes by observing changes in cosmic radiation. The analyses showed that there is a statistical relationship between the two phenomena, but it shows features that no one expected, representatives of the IFJ PAN reported. At first glance, the idea that there is a connection between earthquakes and cosmic radiation, in its original form reaching us mainly from the Sun and from the depths of the universe, may seem strange. However, its physical foundations are fully rational, emphasizes Dr. Hab. Piotr Hamola, IFJ PAN and Astro CNTCAMK PAN. CREDO coordinator and the first author of the article describing the discovery published in the scientific journal of Atmospheric and Solar Terrestrial Physics. The main idea here is the observation that there are eddy currents in our planet's liquid core that are responsible for generating the Earth's magnetic field. This field deflects the charged particles of primary cosmic rays. Thus, if large earthquakes were associated with disturbances in the flows of matter that drive the Earth's dynamo, these disturbances would change the magnetic field, which in turn would affect the paths of primary cosmic ray particles in a way that depended on the dynamics of disturbances in the interior of our planet. As a result, ground-based detectors should notice some changes in the numbers of secondary cosmic ray particles recorded. According to IFJ PAN, physicists from CREDO analyzed data on the intensity of cosmic radiation from 2 stations of the Neutron Monitor Database project, collected over the last half-century, and the Pierre Auger Observatory, collected since 2005. The choice of observatories was determined by the fact that they are located on both sides of the equator and use different detection techniques. The analyzers took into account changes in solar activity, described in the database maintained by the Solar Influences Data Analysis Center. Key information on Earth's seismic activity, in turn, came from the American program U.S. Geological Survey. The analyses were carried out using several statistical techniques. In each case, for the analyzed period, there was a clear correlation between changes in the intensity of secondary cosmic rays and the total magnitude of all earthquakes with magnitude 4 or higher. Importantly, this correlation only becomes apparent when the cosmic ray data is shifted 15 days ahead of the seismic data. This is good news because it suggests the ability to detect impending earthquakes well in advance. Unfortunately, the analyses carried out do not show whether it will be possible to indicate the place of the cataclysm. Correlations between changes in the intensity of cosmic rays and earthquakes are not visible in analyses concerning specific locations. They only appear when seismic activity is taken into account on a global scale. This fact may mean that changes in the intensity of cosmic radiation show a phenomenon that our planet as a whole undergoes. In the world of science, It is assumed that a discovery can be said when the level of statistical confidence in the data confirming it reaches 5 sigma, i.e. standard deviations. We got more than 6 sigma for the observed correlation, which means less than 1 in a billion chance that the correlation is a coincidence. We therefore have a very good statistical basis for claiming that we have discovered a real phenomenon. The only question is whether it's really the one we expected, wonders Dr. Hamola. It turns out that the global nature of the observed phenomenon and the 15-day advance of seismic activity, visible in cosmic radiation, are not the only intriguing puzzles related to the discovery. A big surprise is the large-scale cyclicality of correlations, a phenomenon that no one expected. The analyzers show that the correlation maximum occurs every 10 to 11 years, i.e., in a cycle similar to the solar activity cycle. However, it does not coincide with the maximum activity of our star. Moreover, both cosmic ray and seismic data have other common periodicities of unknown nature. An example may be the periodic changes in seismic activity and the intensity of secondary cosmic radiation in a cycle corresponding to the Earth's sidereal day, equal to 24 hours minus about 236 seconds. So, could the cosmic seismic correlations be caused by some factor reaching us from outside the solar system, capable of simultaneously causing radiative and seismic effects? But what conventional physical phenomenon could even qualitatively explain the apparent correlations? The lack of classical explanations for the observed cyclicality provokes consideration of the possible role of other, less conventional phenomena. One of them could be the Earth passing through a stream of dark matter modulated by the Sun and other massive bodies of our planetary system. The Earth with its sensitive magnetic field is an extremely sensitive particle detector, many times larger than man-made detectors. Therefore, it should be possible that it may react to phenomena invisible to previously used measuring devices. Whatever the source of the observed cyclical patterns, the most important thing at this stage of research is that we have demonstrated a link between cosmic radiation recorded near the surface of our planet and its seismic activity. And if we can be sure of one thing, our observation points to completely new, exciting research opportunities, concludes Dr. Hamola. The International CREDO, Cosmic Ray Extremely Distributed Observatory project is a virtual cosmic ray observatory open to everyone, collecting and processing data not only from sophisticated scientific detectors, but also recorded using a large number of smaller detectors, the most prominent of which are CMOS matrices in smartphones. To transform your smartphone into a cosmic ray detector, just install the free CREDO detector application. The program is available free of charge. For Android smartphones, you can download it from the official Google Play Store or IFJ Pan account. More on this subject in the text. CREDO's main tasks: it is necessary to monitor global changes in the flux of secondary cosmic rays reaching the surface of our planet. This radiation is most intense in the Earth's stratosphere within the so-called regenera Pfadzer maximum, where particles of primary cosmic rays collide with gas molecules of our atmosphere and initiate cascades of secondary particles.